What's going on YouTube? Today we're going to talk about how antivirus works. We're going to split this into two videos. Today we're going to take part 1. We're going to explain some components, detection techniques, and of course we're going to go over some definitions of the antivirus. In this video we'll go over these, and we will also cover how the signature-based detection works. In the upcoming videos we're going to talk about other detection techniques such as heuristic and dynamic. Now let's start with the definition of an antivirus. So there are many definitions of an antivirus. So basically, in simple words, it is sort of extra layer of security. It aims to detect and prevent the execution of malicious files. Malicious files come in different forms. So you may find malicious file in the form of exe, executable, or PDF. It could be DLL. So there are many forms or many extensions or many file types that could be malicious. The antivirus job is to protect the workstation or the computer from getting infected. And so antiviruses come in different forms. We have the traditional one, traditional antivirus. The traditional antivirus works on the premise of predefined or comparing the scanned file to a predefined list of signatures. So basically we have a database. Normally it comes with a database. This database has signatures in here of malicious files or malicious patterns. So what happens when the antivirus starts scanning your computer, it will compare the files on your system with the signature or the predefined signatures in the database. When it finds a match, it will flag the file and tell you there is a virus. Now basically these traditional antiviruses actually need to be updated from time to time, as there are viruses emerging all the time. So make sure all the time to update your antivirus to make sure you get the latest signatures. So basically here the updates of the database is a critical component of how it works. Now we have other forms of antiviruses. So this is a traditional. We have what's called the EDR. So EDR endpoint detection and response. It's a kind of security solution that provides real-time protection against malwares. The EDR works on something called the behavioral analytics. Writing with this pen is kind of hard. So behavioral analytics. So that's how it is different from the traditional antiviruses. An antivirus application performs scanning, detecting, and removing malicious files. On the other hand, EDR or endpoint detection and response monitors various security checks on the target machine, including file activities, memory, network connections, Windows registry processes. So it is kind of more advanced and complicated or sophisticated than traditional antiviruses. It's recommended if you are, have a public server or workstation that contains critical or sensitive data to use EDR. So EDR is more advanced and sophisticated than traditional antiviruses. Okay, now we have gone over the definitions of antivirus. Let's go over the features. The first feature of an antivirus is the scanner feature. That's the first one. So it scans, right? That's how it works. It scans. The main component is the scanner. The scanner feature is included in most antivirus products. So basically antivirus software runs and scans in real time, or you can click on scan. So basically this is called in-demand scan. So the scanner actually, it looks through the files and directories in your system, and when it finds a match in the current database or its database, it will trigger an alert or it will flag the file. The scanning feature here, guys, must support the most known malicious file types and to detect and remove the threats. So the most known malicious file types are the exe and DLL. Okay, yeah, we have PDF, we have malicious, sometimes we have Word documents that hide malicious macros, but it is not as common as the executable and DLL files. In addition, the scanner must support or may support other types of scanning depending on the AV type, including vulnerabilities, emails, Windows, memory, and registry. It depends on the antivirus type, whether it's traditional or EDR. So basically that's the first feature, which is the scanning. The next feature is the compressor and archive. Let's talk about this a bit. So basically sometimes antivirus or viruses come in the form of zip file. Okay. So say virus.zip. So this file, the virus triggers when you extract the zip file and execute the subfiles. Now, when it comes to antiviruses, compressors and archives is a feature that is included in most modern antiviruses. How it works? It must support actually what it does. First, it must support and be able to deal with the right system file types, including the compressed and archive file, because we don't have only zip. We have 7Z, we have RAR, etc. Malicious code often tries to evade antiviruses by hiding in compressed files. So basically, if you download a virus or malware, if you received some malware by mistake from someone, and it is in zip file, your antivirus may not trigger an alarm because the virus is hiding inside a zip file. Now, for this reason, AV software must decompress and scan through all files before a user opens a file within the archive. The feature compresses and archives, it actually uncompresses the file before the user opens it without the need of opening it. So basically, if your antivirus supports this feature, you can find it in your settings, like make sure to activate compressors and archives or uncompressing zip files when you download them or receive them from some source. All right, the third one is parsing and unpackers. Yeah, we know that malware hides and packs its malicious code by compressing and encrypting it within payload. So basically, malware developers use packers to pack the malware and obfuscate it. Technically, it reduces the file size, it changes other characteristics of the malware, so the traditional antivirus won't be able to find it, or actually the signature of the malware could be changed or modified in some way so that traditional antiviruses won't be able to find it. That's why modern antiviruses need to have parsing and unpackers as a feature. So what it does, it actually decompresses and decrypts the file upon receiving. So the AV software must be able to detect and unpack most of the known packers. So a packer is a software used to pack the malware. Some of the packers, well-known packers are UPX packer. We also have ASPack. These are well-known packers that malware developers use to pack and encrypt the malware. So when you activate parsing and unpackers, your antivirus will be able to unpack the malware and be able to find its real signature. So as I said earlier, guys, malware developers use various techniques such as packing to shrink the file size and change the malicious file structure. Packing compresses the original executable file to make it harder to analyze. Okay, therefore, as I said, guys, make sure to activate parsing and unpackers if you have it in your antivirus. Now let's talk about emulators. Okay, so emulator, guys, is sort of, you can say it's sandbox, but the official definition is it's type of antivirus feature that does further analysis on suspicious files. So once an emulator receives a request in your antivirus, the emulator, what it does, it runs the suspect, which sometimes come as executable or DLL. So it runs the suspicious file, okay, in a virtualized and controlled environment. After running the file, it monitors the executable file behavior during the execution. So what it does, it monitors a couple things about the file. The first thing is the system call or API calls. It monitors the system and API calls, it monitors the registry, it monitors the network connection that the suspicious file may initiate. So based on all of these aspects that it monitors, emulators can come up with a result that this file is malicious or this file is benign. Okay, so now the last one is the antivirus engine, which is the most important. So antivirus engine is responsible, guys, for finding and removing malicious code and files. So modern AV software implements solid AV core that accurately and quickly analyzes malicious files. It also handles and supports file types, archive, executable, compressed, whatever. So the engine here is the base components of all antiviruses. Based on the engine, the antivirus may contain these components or features and may not. Okay. Now let's talk about the detection techniques. So antiviruses, we have various detection techniques. We have the signature based, we have the heuristic detection, and we have lastly the dynamic detection. So how these differ from each other? The first one, the signature based, it is the detection technique used by traditional antiviruses. Okay, it is a traditional antivirus technique that looks for predefined malicious patterns or signatures within files. Now, heuristic detection. Heuristic detection is a more sophisticated and advanced technique that includes various behavioral methods to analyze suspicious files. Behavioral analysis, guys, includes analyzing the file's behavior. It's like emulator, right? So it monitors the API calls, registry, network connections, and then it comes up with a result based on the behavior. The last detection technique is the dynamic detection, which includes monitoring the system calls and APIs and testing, analyzing in a threat environment. That's how these differ from each other. So modern antiviruses may include signature-based and heuristic detection at the same time, and also some of them include dynamic detection. So it uses all of these techniques at the same time, or detection techniques. Okay, in today's practical video, guys, we're going to talk about the static detection or the signature based. We're going to explain how it works based on a practical scenario that I will open in a bit. Alright, so in this practical scenario, we have a couple malware samples. This is the first one. This is a test file containing ASCII strings, okay, used to test the effectiveness of the antivirus instead of placing real malware that could damage the machine. Okay, you can find these samples from here. Let me show you guys where. You can download samples from this and test your antivirus. You see, it comes in various formats: zip, text, and other formats. So that's where we brought this. All right, and then we have backdoor 1. So backdoor 1 is a C# program that uses a well-known technique to establish reverse connection, including creating a process and executing a Metasploit framework shellcode. The backdoor 2 is the same, guys. It's a C# program that uses, instead of malware shellcode, it uses process injection and encryption. So it's more sophisticated to establish reverse connection. Of course, it uses Metasploit shellcode, okay, but the technique is different here. It uses process injection and encryption, but here it doesn't use. So basically, backdoor 2 is more complicated or sophisticated. And we have AV-check. Again, AV-check is also C# program that enumerates AV software in a target machine. This file is not considered as malicious or virus. And lastly, we have the notes. Let's open the notes. As you can see, it is a text file that contains command line. Command line, this is it. This file isn't malicious, but the command here is a characteristic of a malicious file. We're going to explain why it has been placed in the notes. Okay, so as I said earlier, guys, we're going to demonstrate how antivirus works, and specifically we're going to talk about the static detection or the signature based detection. First, let's open the command prompt. Okay, I make this bigger. All right, so we're going to navigate to cd program files, cd clam av. Okay, and we will start from here. Clear. Oh, we can't clear here. All right, so let's start from here. So what we're gonna do, guys, we're gonna scan the samples found under this folder. We're going to scan these samples and find out what ClamAV is able to find based on the static detection. So basically what we can do here, we can run clam scan, and in here we specify the folder. So it's C users desktop samples. I think the font is way bigger for my eyes. I'm gonna just make it smaller. Alright, so the scan has finished, and as you can see, guys, from the output, that ClamAV antivirus was able to flag backdoor 1 and this file. So these two files were flagged as viruses. On the other hand, nodes, backdoor 2 and AV check were not flagged or were regarded as not malicious. So basically, guys, the reason for that is, first, backdoor 2 uses XOR encryption. As I told you in the beginning, it uses process injection and encryption to hide its characteristics, the bytecodes, the strings. All of these are characteristics the antivirus looks for. So these are hidden and obscured or obfuscated actually by the use of of backers and other techniques. That's why ClamAV was not able to flag backdoor 2. Now nodes is a malicious file, and AV check was not also a malicious file. So while, as you can see, guys, the ClamAV was able to detect the eCar test file as malicious using the MD5 string technique. How do we know that? What we can do, guys, we can use here a feature called a debug. So we can use --debug. Okay. And using --debug, we can see all modules loaded and used during the scanning. For example, let's see how ClamAV was able to flag the eCar as malicious. So we define the file, or we give it the file name, and we use the option --debug. We want to find out how the ClamAV was able to flag the file. Based on what? Based on what characteristic of the file? You will see that it was able to flag it as malicious based on the MD5 signature. So to confirm this, we are actually now rerunning the scan in a debug mode. We should be able to see a message that's saying this characteristics was what triggered the antivirus alarm. Okay, guys, as you can see, the scan is finished, and the ClamAV flagged the ecar.com file as malicious. Okay, we want to find out how. So as you can see here in this line, FP signature, and here what seems to be an MD5 hash. So ClamAV was able to flag this file as malicious based on its MD5, because its MD5 is stored in the ClamAV database as a malicious characteristic or malicious signature. It was able to flag the file. Now let's calculate the signature of the eCar and match all of these characteristics together. Okay, so to do that, we're going to use the signature tool. So sig tool --MD5, and then we're going to give it the path to the file. Samples and then eCar. Take a look at this format. So as you can see, we have the MD5, okay, and then we have the file size, and here we have the name of the file. So this is the MD5 of the file, and as you can see, it matches the MD5 found here. Okay, so what if one of the characteristics of the file, such as the MD5 or the bytecodes or some of the strings, were not in the antivirus database? What's going to happen? It's not going to be able to flag the file as malicious. As you saw here, guys, the backdoor 2, for example, and AV check were not flagged as malicious, although they contain malicious characteristics. So what do we do in this case? We're going to need to update the database of the antivirus. That's how static detection works. If the predefined signature or pattern does not exist in the antivirus database, your antivirus won't be able to flag the file, no matter how old the virus, no matter how easy or simple it is. So we need to create, or we need to add one of the characteristics of the file to the antivirus signature so it can detect it. Fortunately, ClaimAV allows us to add signatures to its database. Okay. To do that, first we're going to need to calculate, as I told you guys, the MD5 hash, which of the backdoor file. The first thing, seek tool --MD5, and then we're gonna give it the path to the backdoor. So we start with calculating the MD5 hash of the backdoor. Okay, take a look at this one here. As you can see, we have the hash, we have the file size, and we have the name of the file. Now, after we have generated the hash, guys, we need to add these information to the database of the antivirus. How can we do that? We use the same tool, signature tool. And then the path of the file to. So for the sake of today's tutorial, we're going to name it THM, as this is part of TryHackMe tutorial. THM dot, and the extension of the database needs to be HDB. Access denied. This is cool. Signature tool --MD5. So let's store this somewhere else other than here. So what we can do, we can do this and copy that. How about this one? So I think we were successful. Let's check the database. As you can see, database has been created. Now what we're going to do, guys, we're going to rescan backdoor 2 with this database file, okay, to see if ClaimAV now is able to find out if it is malicious or not. So let's see. So now we are in the same directory. We use ClamScan, okay, and then to specify the database, we can use the option -D and specify the path to the database. All right, and then the file. The file is here. And as you can see, guys, here, it flagged the file as infected. Infected files 1, and this is the result. Backdoor 2, unofficial found. Unofficial found because we actually added the signature ourselves. There are many tasks to do when you add a signature, including the description of the malware, the author, all of these characteristics or aspects of the malware. But we only, for the sake of this scenario, we only added the MD5 hash, right? Just to see if it will work or not. So basically now it worked. We were able to flag the backdoor 2. Now that's one method of updating the antivirus database, creating your own signature. Now there is another way, which is using Yara rules for static detection. So if you remember, guys, we have the AV check here. We're going to apply Yara rules on this file. We're going to create Yara rules to be able, or to enable the antivirus to flag this file. The first method was to create a database file. Okay, this time we're going to use Yara rules. So Yara, as you know, guys, is a tool that allows malware engineers to classify and detect malware. It uses rule-based detection. Similar to signature-based detection, Yara uses rule-based detection. So in order to detect a new malware, we're gonna have again to create a new rule. Okay, so fortunately for us guys, ClaimAV can also deal with Yara rules to detect malicious files. The rule will be the same as in our database in the previous example, where we detected backdoor 2. So to create a rule, we need to examine and analyze the malware. Okay, we're gonna need to find out the characteristics, the bytecode, whatever. Based on the findings, we can create or proceed to create the rule. So let's now check, guys, the file here, avcheck, as an example, and write a rule to create the file. First, we're going to need to analyze the file and list all of the strings. One of the ways to create a database signature or Yara rule file is to find out what are the strings contained in the file. We're going to list all of the human readable strings in the binary using the strings tool. We're going to see the functions, variables, bytecode, all of the nonsense strings, right? So let's do that. Okay, so now strings, and we define the path. AV check. You see we have many nonsense strings. If you look closely, we can use some of this unique strings here in our rules to detect this file in the future. So if you look, let's take a look at these strings. As you can see here, let's see. Text, strings. When I find out some sort of string, this actually is a string file. We can use it in the Yara rule file. This one is kind of unique, right? But we're not sure about this. And here is a flag. I think this is useful. Let's copy that. Let's copy this flag and see what we can answer. Use the strings tool to list all human readable strings of the AV check binary. Okay, which is the signature tool output to generate an MD5 of the AV check binary. What is the signature tool output to generate an MD5? We're gonna do that now, guys. Now let's get back to the strings, and we're gonna need to look for unique string, guys, to use it in the Yara rule that we are about to create to flag the AV check file. Let's see. So this is it. All right. So if you didn't find any string, yeah, we have this one. Look at this one. We found something. Look at this path. So as you can see, the AV check file uses a program database PDB extension, which contains a type and symbolic debugging information of the program during the compiling. So this is the path. This path is considered as a unique string. We can use it to create a Yara rule to be able to detect the file in the future. So we will use this path, okay, as our unique string in the Yara rule that we are about to create. The signature could be something else in the real world, as you know, guys, but that's how you do it. For example, registry keys, internet connections, IP addresses, whatever, domain names. All right, so now let's write a Yara rule here. Let's open a text file. New, and call it AV check. Okay, so rule AV check detection. This is the name of the rule. Okay, and then we use some indentation, meta. We write information about the author, the description, author equal. We're going to say it's THM, TryHackMe. We have R here. Okay, and then the description. So we're going to write detecting false or malicious files. Not exactly, detecting AV check file. Alright, now let's try the strings. So here we define what are the characteristics we are looking after, or we want. So if you go up, the unique string here is this one. It's the path of the database. So let's put it in a variable, a equal, and we're going to use additional backslash to escape the special character. And after we wrote the description, the meta strings, lastly we want to write the condition. The condition is to match the path. This is it. Alright, so let's go over the rule again, guys. So first, the rule starts with AV check detection, which is the name of our rule. Clam AV uses this name if a rule matches. Okay. Now next we have the metadata section, which is general information about the author and the description of the file or the Yara rule. And then we have the strings section, contains the strings or bytecode that we're looking for. We're using the, as you can see guys, the program database path in this case. And lastly we have the condition section, which specify if the defined string is found in the string section, the flag is file. As you can see, it's defined by the variable a. Now Yara rule, we created the file in Notepad, but we need to store the Yara rule in .yara extension, okay, for the claim AV to deal with it. If you store it in text file, you won't be able to use it. Let's actually now file, save, and name this .yara. Close. Let's take a look. So we have the Yara file created here. Let's delete the first one. Okay, so the AV check is here. Let's now scan the AV check executable with the claim AV and see if claim AV now is able to flag the file. So clam scan -d, we specify the Yara file that we created. So in this case, let's copy the path. AV. Okay, so this is the Yara rule file, and lastly the path to the file, which is AV check. Okay, as you can see, infected files 1, and here the description is, as you can see, AV check was flagged by Yara detecting AV check unofficial found. So that's how, guys, we use Yara rules to detect or flag malicious files that or whose characteristics are not found in the signature or the database signature, guys. So that's how you do it. Now let's see if we have questions to answer. So I answered this one. Use the signature tool to. What is the signature tool output to generate an MD5 of the AV check binary? Let's see. So signature tool --MD5, and then we copy the path to AV check. And this is the output. Okay. In the next video, guys, we're going to talk about dynamic and heuristic based detection, which cover the other tasks. We have other questions, I guess, here. The antivirus features. Which AV feature analyzes malware in a safe and isolated environment? It is the emulator. A feature is a process of restoring or decrypting the compressed executable files. It's the unpacker, and that was it, guys. So in the next video, I told you guys we're going to go over the dynamic detection. Thank you for watching, and I will see you in the next video.